Hello, since it's a fairly cold day today, I thought I was going to go back to working on this color transformer project that I was working on. And I was in the middle of doing some coding when it just about threatened to crash on me. And I didn't want to have that in the video. So unfortunately, I'm not going to be able to show all of the thought processes behind what I did. And I'm just going to have to show the final results. In the last video, I had shown how to set up a new Maven project, create a basic template, and in this video, the next thing that I wanted to do was to be able to have the original image that is loaded side by side with the image that has the colors manipulated. And in order to do that, I needed to figure out where to place those images in the output canvas. So the way that I ended up doing it was I created an inner class, a private inner class to my canvas that contains 2 points. The first point is the upper left of the image, the original image, and the second point is the upper left of the modified image. Both have the same width and the same height because the modified image is a duplicate of the original image with additional pixel color transformations. So they're both going to be the same size, same color, 24-bit, etc., etc., etc. So for this exercise, you can treat them both as being the same image. The next thing that I did was I needed to render, I needed to draw each image in at different coordinates in the output. The first, the original image has a top left X and a top left Y, and this requires the top left and the bottom right. So I have to add the image width and the image height to the top left coordinate to get the bottom right. And I'm drawing the full original source. And you can look at the graphics 2D API to find out what all of these parameters mean. Then I did the same thing again for the copy or the manipulated image, this time using the modified image top left. I had to compute the stacked image coordinates, and I should probably, for efficiency, only do it when necessary, and when necessary would be when I load a new image or when the size of this component changes. So I would probably want to add a resize listener to this class, and then whenever it gets resized, set a flag to say that I have to recompute this. But for now, I'm just going to leave it like this, and I'm going to recompute it every single time the image gets drawn. And in this application, I don't think that the performance really is that critical. And then finally, in order to calculate the aspect ratio, since the image and the original image are controlled by this class here, they both should have the same aspect ratio. So technically, I don't really need the modified aspect or even the output aspect, but I'll leave them in for now just in case this tool has to be expanded later on and the output gets cropped, for example. And the cropped image could have a different aspect ratio. So the way that I calculate where it should be placed on the screen, I get the canvas width and the canvas height. And then I calculate the output aspect ratio by dividing the output width by the output height. I get the original image width and height, calculate the aspect ratio for the original image in a similar manner. At this point, the modified width and the modified aspect, the modified width and height and aspect ratio are completely irrelevant. I'm expecting the modified image to be the same properties, to have the same properties as the original image. And if the image is landscape, I want the original to be at the top and the modified to be at the bottom. If the original image is portrait, I want the original on the left and the modified on the right. And to do that, if the original image aspect ratio is greater than 1, then I want them one on top of the other. And so what I end up doing is, given the height being the top half, I calculate the required width by multiplying the height by the original aspect ratio. That will give me a scaled required width. Required height is the output width divided by the original aspect ratio. If the required height ends up being wider than the output width, then I have to scale the width down so that the scaled output fits in half the height. So I would end up having black bars on the left, or rather I would have bars on the left and bars on the right. And I choose the appropriate variables in this case. I also set the X and the Y coordinate, which becomes the original top left. And in this case, if the output width is less than, if the required width is less than the output width, then the image width will be that, but the image height is going to be yeah, that's right. So the image width will be whatever width I need, and the height is going to be the top half of the canvas. I set my X and my Y accordingly, and then over here I set my data points. And then if I stack them side by side, I do similar calculations, but for the other way. And so first I'm going to run it with a vertical test image. And what that should do is that should give me the two side by side. And it turns out that there are these bars, there are these gray bars on either side, like this here, so that is correct. And unfortunately, the width doesn't scale, but the height does. And if I switch over to use one that is landscape mode instead, here we have these bars on either side, but if I scale it, you can see that it stretches until it gets to the point where now it puts the bars on the top and on the bottom. So at this point, I now have a canvas set up to draw the original and the manipulated image on the bottom. And the next thing that I'm going to work on is going to be to transform all of these individual pixels to match whatever data transformation is required to simulate a certain color blindness. And so that's going to be in the next video. So hopefully I'll be able to make the next one soon. Thank you for watching, and I'll see you again in another one.